Hi everyone, got your pre-calculus practice test 7 going here, and we'll start out. The first page here deals with sequences and series, and number 1, find the first 5 terms of the sequence described by a sub n equals 3n to the third minus 5. So the first 5 terms, and this question was asked, good question. Do we start at 0, 1? We'll start at 1 unless it tells us to start at 0. So for the first term, we'll do n as 1, 2, 3, 4, and 5. And then it's a simple case of plugging for 1, plugging 1 into n. 3 times 1 to the third minus 5. 1 to the third is 1. 3 times 1 is 3. 3 minus 5 is negative 2. When I plug 2 in there, 2 to the third power is 8. 3 times 8 is 24. 24 minus 5 is 19. Plug 3 in. 3 to the third power is 27. 27 times 3 is 81. 81 minus 5 is 76. When I plug 4 in, 4 to the third power is 64. 3 times 64 is 192. 192 minus 5 is 187. And plug 5 in. 5 to the third power is 125. 3 times 125 is 375. Subtract 5 from that and you get 370. So if we wanted to write them in a row like this with the commas, we would do so. All right. Number 2, I'm not going to spend the time on the video to do this. It's probably a little more involved than I meant for it to be. So when you do number 2 on the test, it will be a bonus question. So we will leave it at that. Now number 3 and 4, we're going to write the first 5 terms of the arithmetic sequence. Now, they tell us the first term on number 3, it's 3. D is 4, the common difference. So we just add 4 each time. 3, 7, 11, 15, and 19. There's 5 terms. On A4 and A10, they give us the 4th term, they give us the 10th term. I'd really like to figure out what the first term is and then figure out what the 10th term is. The 4th term is 10. You got your 5th term, your 6th term, your 7th term, your 8th term, your 9th term, and your 10th term. You've got 28. Whoops, up here. 28 up here. This is the 10th term here. Not to be confused with a fraction. That's just the little indicator of which term it is. So the key thing is to figure out what that distance is. One of the formulas that will be on your test, it's at the end of your test, is this one that indicates if you know the term number and you have the first term and the common difference, you can get any term that you need. So if I kind of just adjust so that I'm thinking more of this as the first term, 2nd, 3rd, 4th, 5th, 6th, and thinking this one is the 7th term, then the 7th term is 28. The first term is 10, just shifting everything 3 units over in our thinking. And 7 minus 1, n is 7, and then D. This lets me find out what's this common difference we're getting to get from 10 to 28 in the 4th term to 10th term. And notice the only unknown here now is D. So 28 equals 10 plus 6D. If I subtract 10, I got 18 equals 6D, and if I divide by 6, Here now I know D is 3. Now, you've only got 4 here. My fourth term is 10. If D is 3, the term before it is 7. Term before that, 7 minus 3, is 4. And the term before that is 1. So I'm adding 3 each time. And then I'll add 3 to the other end of 10. And I've got 13 there. So just figure out what that common difference is, and you can work backwards. Okay, so number 5, I'm going to go here, and I'm going to use this formula up here again. A sub n equals a sub 1 plus n minus 1d. A sub n is what we're solving for. A sub 1 is 100 plus n stays as a variable to do the general formula, and d we're given as negative 3. So the nth term is a 100 plus, let's distribute this. Let me change the plus to a negative 3n, and negative 1 and negative 3 is positive 3. So here's my nth term, negative 3n plus 103. Okay, so I did that. I found the formula for a sub n. And now I want to find the sum of the first 25 terms. And I'm going to write the other formula that will be on your test. The sum of the first n terms is n divided by 2 times the first term plus the nth term. So, A1 we know is 100. We want a sum of the first 25 terms. In this, we do need to know what that 25th term is. So I'm going to use this formula. Negative 3 times, let me put a box on this so the 25th term, negative 3 times 25 plus 103. That's negative 75 plus 103 is, let's see, 28. So the 25th term is 28. To find the sum of the first 25 terms, which is what this is wanting, we take 25 divided by 2 and we multiply it by the sum of 100 plus 28. And that's 12.5 times 128. If I just is 1,600. So the sum of the first 25 terms is 1,600. Come on in. Hello there.
Hey there. We actually are going to go into the chapels.
Okay.
Are you working on the video right now?
I am, yes. I'm going to pause it for a second here. All right, I think we're good to go. All right, 5's done. 6, the first problem is 10. The third problem is 28. Now, we have to come up with D. One of the ways, we've got to add whatever D is, we've got to add it twice. When we add it twice, we have 18. 28 minus 10 is 18. Split that evenly 2 ways, and your D is 9. All right, so the general term, again, a sub n equals the first term of 10 plus n minus 1 times d, which is 9. So it's 10 plus 9n minus 9. And 10 minus 9 is 1. So 9n minus 1. A sub n is 9n minus 1. Okay, so we also need to know the 25th term. So 9 times 25 minus 1. That's 225 minus 1, which is 224. Now, the sum of the first 25 terms is 25 over 2 times 10 plus 224, which is 12.5 times 234. And I'm getting 2,925. Okay. Now number 7, for j is 1 to j is 10, we're going to add after we substitute into that expression, add all the terms. The first term is 2 times 1 minus 3, which is negative 1. The second one is 2 times 2 minus 3, and so on till we get to here's the first term. Let's keep going till we get to the 10th term, which is 2 times 10 minus 3, which is 17. So I'm going to add negative 1, I'll put pluses here, okay, plus all the 8 terms in between, and to 17. And I'm going to use this formula again. So the sum of the first 10 terms is 10 divided by 2 plus, or times negative 1 plus 17. And that is 5 times 16, which is 80. Okay, so this is equal to 80. All right, next. Make sure you're adept at making, I've only taught you using Pascal's triangle. I think getting to the 7th power will be sufficient. Yep, we got one with the 7th power on it. And I don't think I'll go any higher than that tomorrow. Okay. And I didn't go over how to make that, but I'm going to just leave that to you to get that done. X plus 3 to the 5th power. My coefficients are 1, 5, 10, 10, 5, and 1. That second number in the row is always the same as the power. 1, 5, 10, 10, 5, and 1. Then beside each coefficient, I'm going to write x, and then I'm going to write negative 3. So let's write the x's down first. And then let's write the negative 3's down next. And then the powers of 5. We start at 5 and we descend. We go 5, 4, 3, 2, 1, and 0. The powers of negative 3, I can start here and go to 0. I've been tending to start over on the right and do the same thing, but go right to left instead of left to right. I'm going to put a plus in between each one of these. And then I'm just going to simplify each term. 1 here, 1 here. 1 times 1 is 1 times x to the 5th. This is 5 times negative 3. So that's minus 15x to the 4th. This is 9. 9 times 10 is 90, so plus 90x to the 3rd. I'm just taking the negative 3 to the power and multiplying it by the coefficient for the new coefficient of our final answer. Negative 3 to the 3rd is negative 27. Multiply that by 10. I got negative or minus 270x squared. Negative 3 to the 4th power is 81. 81 times 5 is 405, and that's x to the first. This is 1, this is 1, negative 3 to the fifth power. I think we've checked that as negative 243. So this is a little quicker way of getting through this, just knowing the binomial theorem. And the 3x plus y to the 7th power. That's that 1, 7, 21, 35, 35, 21, 7, and 1 row. So I'm going to write that out and spread out here a little bit. 1, 7, 21, 35, 35, 21, 7, and 1. And I'm writing a 3x beside each one. And I'm writing y beside each one. And the 3x powers start at 7, 6, 5, 4, 3, 2, 1, and 0. And the y powers 7 from right to left, 6, 5, 4, 3, 2, 1, 0. And these powers will always add up to the 7. 6 plus 1 is 7, 5 plus 2 is 7, 4 plus 3 is 7. That always, I don't know that we said much about that, but that always happens. All right, so 3 to the 7th power is 2,187. And everything else is 1. So 2,187 x to the 7th. 3 to the 6th power times 7. The coefficient is 5,103. Well, this is a doozy. 5,103 x to the 6th. 3 to the 5th power is 243, and I multiply that by 21, and I'm at 5,103 again, and I'm down to, oh dear, dear, dear. Okay, I forgot the y to the first here. I got x to the 5th. I need y to the 2nd here. All right, we're back on it now. 3 to the 4th power is 81. 81 times 35 is 2,835. And then the x is to the 4th power, and the y is to the 3rd power. 35 times 27. 945. So that's 945. X is to the 3rd, y is to the 4th. 21 times 9 is 189. And then I got x squared, y to the 5th. 7 times 3 is 21. X, y to the 6th. 1, 1, and I have y to the 7th at the end. All right. Impressive looking. Easy, but impressive looking. Okay. Now, we're into the counting problems. And we got to decide, is it a fundamental counting principle, where you just multiply at each stage, or is it a permutation, or is it a combination? That's what we have to decide here. Number 10, the ski club with 10 members, that's where we're choosing from, that's our big group, is to choose 3 officers, captain, co-captain, and secretary. How many ways can those offices be filled? So the order does matter. The first person listed is the captain, the second's co-captain, the third's secretary. If we had the same 3 people and changed the order, they would have different responsibilities. So that's why that is a good choice for permutation. We have 10. We're choose from 3. On this calculator, I have to hit 10 first, and then I hit the math button. I go over to PRB, and there's the NPR button, and then, okay, I don't know if this is going to work. I think that's a 10 still, but I think I hit another button, and I believe that is right, but let's do it again. 10, math, PRB, NPR, 3, enter, 720. So there are 720 different ways of making officers for these 10 members. The order does matter there. Number 11, election ballot asks voters to select 3 city commissioners from a group of 6 candidates. In how many ways can this be done? Now on this one, the order does not matter. So I'll put a C, and that's a combination. This is a permutation. If I have the 3 people listed in a different order, it's still the same commissioners. It's still the same commission. It's not a different, they don't designate the responsibility. So 6, and sometimes we say choose 3 for combinations. And 6, math, PRB, now NCR, and then 3 is 20. There's 20 different councils that could be made from 6 candidates. Hi there.
Do you know where Mrs. Summers is?
I think they are all in the chapel.
Okay, thank you.
You're welcome. All right. Live TV, guys. Now, number 12. Okay. And we did kind of address this. Let's go ahead and calculate 10, choose 3, and we get 120. And the permutations, 10, math, PRB, NPR, 3, 720. I already had that. I didn't realize that. Okay. Why are there more permutations than combinations? The order matters with the way the 3 objects are listed. Here, the order does not matter for the 3 objects listed. Let me just put that for both. For the 3 objects listed. All right. Now, number 13. A men's department store sells 3 different suit jackets, 6 different shirts, and 8 different ties, and 4 different pairs of pants. How many different suits consisting of a jacket, which we have 3 choices, a shirt, which we have 6 choices, a tie, which we have 8 choices, and a pair of pants, which we have 4 choices. And you just multiply your choices together. So this is the fundamental counting principle. 3 times 6 times 8 times 4 gives me 576 different suits. Now there might be some real subtle differences between some of those suits, but now number 14 is a little more to it than what I was hoping for, but I have a 4-digit number. I like to just, if I have a digits or characters or something, I like to just draw lines to kind of represent. It has to be an odd number. So the last digit has to be 1, 3, 5, 7, or 9. It doesn't matter if these are 1, 3, 5, 7, 9. But this one, if it's going to be a 4-digit number, this shouldn't be 0. So my choices are 1 through 9 there. My choices here are 0 through 9. And my choices here are 0 through 9 for those 2 middle digits. I have 5 choices here. Okay, so I'm going to start there, that this last digit has to have 5 choices. Over here, I have 9, except we can't repeat digits. That was said here. If we cannot repeat digits, then this is 9 choices. I have to take one of the choices out because it's one of these numbers is in that group. Now I have this number here and this number here. I have 10 choices, but I'm taking 2 of them out. And here I have 10 choices. I'm taking this number out, whatever it is, whatever this number is, whatever this number is. So I'm down to 7 choices there. 8 times 8 times 7 times 5 is 2,240. Won't be, I'm feeling the test won't be quite as involved with that one. Okay, number 15, the standard configuration for an Alaskan license plate is 3 letters. So A to Z, A to Z, A to Z, followed by 3 digits. 0 through 9, 0 through 9, and 0 through 9, A to Z. That's 26 choices for the first 3 characters, and 10 choices for the next ones. So I'm just going to take 26, I'll raise it to the 3rd power, times 10 to the 3rd power, and get a lot of choices there. 17,576,000 different plates there. Okay, that does that.